Right, hello everybody. This is a short video just to go through Spearman's rank again. So this is for those, about half the class sent work in and then half didn't. So this is aimed at the half that didn't. And hopefully this will make things a bit easier for you. So you can see on your PowerPoint here, there are three things I want to achieve in the next few minutes. The first is why we use Spearman's rank. The secondly is how it's done. And the third is how to interpret the results. So that's what you need to do. You need to make sure that you're splitting this into three blocks, okay, and that'll make it easier for you to understand. So why do we use Spearman's rank's correlation coefficient? Well, it's a bit like a scatter graph. It's for assessing correlation between two sets of data. So if you think back to where you've used scatter graphs in the past in maths, why do you use a scatter graph? Because you're trying to look, aren't you, about how two sets of data are linked together. What Spearman's rank does is it gives a numerical measure. Its result is a number. And what that means is you can then quickly assess how strong correlation is. Remember, with a scatter graph, you can see a pattern there. And obviously you can put your line of best fit in. But what it won't necessarily do, say there's a few outliers, it won't really give you a measure that includes those outliers about how strong that correlation is. Okay, so sometimes we actually want to know whether there's a strong correlation or not. So that's why we use it. Remember, correlation is a word we use to describe the relationship between two sets of data. For example, for musicians, there is a correlation between time spent practicing and the quality of their playing. Also, there is a strong correlation between GDP per capita, so how wealthy the average person is in a country, and energy consumption per capita. In other words, how much energy they use. Okay, I'm not going to get into why that is, but hopefully you can all understand that that's the case. Okay, and that's what we mean. Okay, so it's not just a link, it's as one goes up, so does the other. So as people become more wealthy, more energy is consumed. As people spend more time practicing, the quality of their playing goes up. Okay, so now we're going on to the second part of this introductory video, which is how it's done. So this is then broken down into a series of stages. What I've tried to do for this one is actually just give you a little bit less data, just to make it a little bit easier to work with. Okay, so first thing you do is you put your data into a table. Now, a lot of the time you will actually get a table like this first of all, but say you've collected some field work, you need to make sure that you can put it in a table like that. At the moment, it's in order of the codes, the codes within Breckland where these measures were taken. So what you then need to do is add in a column here, rank 1, and then a column here, rank 2, and then you actually put numbers in to show what the rank order is for each one. So for example, Breckland 03B, that is the most deprived, because it says, look, where 1 is the most deprived, so that's the lowest number. Okay, and then you look up and down. You have to use very carefully with these sorts of numbers. You've got 2 there on 11,000, but that's the lower one, so that's your number 2. And you carry on like that until you get down to number 10. Okay. Then you do the same for this column. All right, so there's your number 1. It's just short of 12,000. And again, just go through very carefully, but sometimes you'll get numbers that look quite similar. And there's your lowest there, which is 25,000. Okay, so that's, remember, in this case, this one here is less deprived. This one here is more deprived. Okay, right. So you put the rank order in. All right, this is where, like I say, it's quite easy to make mistakes. So just check that before going on to stage 3. What you then do is you've got your 2 rank orders now, rank 1, rank 2. You then need to calculate the difference between these two. So you simply take rank 2 from rank 1. So 8 minus 6 is 2, 7 minus 8 is minus 1, and so on. all the way down, you'll notice that these numbers are quite small, which might give you a clue about what the result's going to be. Apart from this one, which is, funny enough, one of the Deering ones, actually. So it ranks 6 for the employment. Okay, so very much in the middle. But it came out worse for health. Okay, 1. So there was a 5 point gap there between the ranks. Okay, once you've done that, you add another column, and that's the difference squared. And you simply square each. So obviously 2 squared is 4, 5 squared is 25, 0 obviously stays at 0. Okay. Once you've done that, you need to add up all these differences. And that's why I put the 40 in brackets, because that's the answer for this one. So 4 plus 1 plus 4 plus 1. Yeah, carry on that down, and then you'll get 40 on this one, this particular example. Next stage. If you haven't done already, this is where you need to get the formula out. Okay, this is the formula I want to use. So Spearman's rank is 1 minus 6 sigma d squared all over n cubed minus n. Okay, the d is the differences, the n is the number of pairs. In this case, there are 10 pairs. So you calculate the top line first. So 6 times sigma d squared. Well, I've already told you that adding all these up, the sigma d squared, that equals 40. So that's what that means. So sigma d squared is all of these added up. Multiply that by 6, and you get, in this case, 240. Right, then go back to the formula again. You need to the bottom line, which is n cubed minus n. So nice easy maths, because there's 10 pairs of values. Obviously 10 cubed is 1,000. Take away 10, you get 990. Right, then on to the next stage. Okay, still keeping the formula there. Calculate the formula as a whole. So 1 minus 6 sigma d squared, which is 240, divided by 990. Keep the 1 minus in there, so it's 0.24. Okay, and then your result then is 0.76. Woohoo! You've got a result. All right. So you look at this, see what Sir's done there. I just realised I've transcribed that wrong, because I put 0.76 there, I put 0.74 there. So this is what I mean about being careful. Okay. However, the important point now is you get your result. So what? And I did have a politer email than that on one of you saying, I've got the result, I don't really know what it means. Okay, which is a perfectly nice, specific point to make, not, oh, I just can't do this, I give up. You've obviously got this far and you wanted to know the answer to that particular question. So there's 2 ways that you can interpret the results. This is the basic one. There are problems with this, which I'll tell you in a minute, but it is a good rule of thumb. Okay, if your number is between 0.7 and 1, or between minus 0.7 and 1, these grey areas here on this chart, then there is a significant correlation. Positive here, negative here. Okay, our number, which I say should be 0.76, this is greater than 0.7. Therefore, there is a significant positive correlation. That's how you write it out at this point. Okay. This means that you can reject the null hypothesis. If you remember, the null hypothesis is the idea that this could all have happened by chance. So because you're in this area here, okay, you can absolutely reject the null hypothesis and say there is a significant positive correlation between the 2 sets of data. Okay. Now, the better way to do it is to use what's called a significance table. And the reason it's a better way is because of this down the left-hand column, because clearly the amount of pairs that you're measuring is going to make a big difference to how reliable your data is. If you only ask 2 people, in this case, if you only ask 5 people, you know, a couple of questions, or if, you know, if our data was based on only 5 sample points, 5 pairs, the chance of this data being quite random or something happening by chance is really quite high. So, you really want to be asking as many people as possible. And this table will reflect that, because if you look down here, this is the one we need to look at, 0.05. You would need a Spearman's rank of 0.9 for it to be significant if you're only asking 5 people, or if you've only got 5 sets of data. If you come down to 30, which is normally the minimum size for reliable data collection, then it's actually only 0.3. Okay. You don't need to worry too much about these tables, just to know that you need to get the right one. So you need to make sure it's a Spearman's rank table. They have been created by statisticians, not just randomly made up. And they do take into account, say, how many pairs of values you're using. So for our study, there were 10 pairs of values. So you look at this row here. You always check in geography the 0.05 column, because, like I say, this is the standard column. If you can get your result from here, we would say that there is a significant correlation. Okay, 0.74 or 0.76, you say this is greater than this figure here, which is 0.564. Therefore, there is a significant correlation. Okay. The one we did the other day, if you remember, it was higher than this, but it wasn't 0.4. So there was not a significant correlation. And, quite often when you do this for fieldwork or even in exam questions, you will get that result. There doesn't have to be a significant correlation. So, you just got to say that if that's the case. Okay, right. Finally, use the same method if you get a minus number. So let's just say it was minus 0.74. You just do exactly the same thing. You ignore the minus to begin with. But then when you describe it as a negative correlation. So don't worry about negatives so much. Like I say, just ignore the minus sign to begin with. Look up your data and then give your result from there. Okay. Right. So hopefully that clears a few things up. Some things to bear in mind. This only tells you there's a correlation. It does not mean that one causes the other. So although there's a correlation between employment and health, so the more people there are unemployed in the area, the more people there are that suffer from poor health, it doesn't necessarily mean that one causes the other. And if you think about it, that's actually quite important, because does unemployment cause poor health, or does poor health cause unemployment? And of course, in reality, it's probably a bit of both, and there may be other factors involved as well. What this doesn't do is give you an explanation. So that's why you need other types of data apart from quantitative data. Okay, quantitative data is good for finding patterns and trends, but qualitative data is good for finding out the reasons for those patterns. So if I was doing this field work and I got that result back here, what I would then want to do is go and do some further investigation in the area that I'm looking at, or the areas I'm looking at, to try and find out what's going on. Are there many cases of people that have struggled to get work and they're then also quite poorly, or which came first, if you like, the chicken or the egg, or is there a balance between the two? Maybe even if I was doing research at a higher level, actually going interviewing people in depth and finding out a bit about the stories that are behind these numbers. So that's where your qualitative comes in. And for changing places, you do need both, really. You need to see what the patterns are, but you also need to find out the reasons behind those patterns. Okay, so before I finish, just to remind you, those are the 3 things. So if you're struggling with this, break it down into 3 sections. I'd almost do like a different page on each. So number 1, set of notes. Why do we use Spearman's rank? Number 2, set of notes. How is it done? Number 3, set of notes. How to interpret the results. If you do that, it should be a lot clearer. And then when we come on to chi-squared, you'll be in a much stronger position to do that other statistical test that we've got to do. Okay, so thanks for that, everybody. Hopefully that's useful, and I will see you all at 2:15 if you are watching this today. Otherwise, I know there's a couple of people who've got Wi-Fi problems. We will catch up soon.